Yeah, like important things for a validation library like this is like baseline performance needs to be good enough. I think the thing that you alluded to a second ago, type performance actually becomes a big deal. So for anyone who's like, I'm not picking on Zod here. I'm just going to say Zod because I've used it in like a big production code base. If you have like a lot of z.infer schema where you're taking your validator and you're getting a TypeScript type that's generated out of that, that can actually be really, really slow for type checking. And especially if you just have like a lot of them. So I'm curious is like how you or how ArkType does that and like the performance trade-offs of that. And then one thing that I want to talk about like after that, which is like the other really big important thing for validators is just like good errors. Because like if you don't know, like the whole reason of doing runtime validation is to like, we want to match the logic in our types with like these runtime checks, but you also need to know like what's going on. And like, it can be really easy to just get like this array of, stuff back that says, oh yeah, it's like this deeply nested key has an issue and like tells you nothing. So I'm curious about those two things.
Okay, cool. So the first thing, like I said, so I built this like a type benchmarking library, a test. It's also for type. I guess I kind of built it for type testing where I could do assertions like, a test like some value, equals this at runtime, and then like dot type dot toString and like snapshot the type representation, or like, snapshot type errors, or like snapshot type completions. And like there's literally no other library in the ecosystem that does any of that. So like people should use it if they're writing libraries, because like, I mean, I don't really care in terms of like, I'm not like really trying to promote a test or whatever, but I'm just like, if you really want to have like robust type level functionality, like you need something that can make assertions about those things, because like just using the built-in stuff in like vtest or whatever that just like checks if two types are the same or something, that is better than nothing. But like if you're building a library where types are a significant part of the functionality, you really need a lot more than that. So I guess that's my tangent shout out to like having more robust type testing. But basically, really, like it's very absent in a lot of like major libraries in the ecosystem that make a lot of use of that type level functionality. And same with like type level benchmarking, obviously. Like people just aren't doing it. So I think the biggest thing is just like I said before, I was sort of had like benchmarks for all the individual expressions that were being parsed and like all these scenarios in ArkType to make sure that whenever I made changes to the type level parsing, that there were no significant regressions in performance, or at least that, like I said, if I'm adding some feature I think it's important and like gives better detailed type error messages or something, like I can make those trade-offs knowingly and say like, okay, this is worth the like 3%, overhead in type checking performance or something like that. And I think most people just have no idea. And it's like, it's just, you can't really have good enough intuitions, even if you've done a ton of this stuff, to be confident that like whatever changes you make, you might not have just accidentally like nuked your type performance by 50%. Like it's just way too easy to do something that seems completely arbitrary and just like it's a disaster. I still see that happen. It like really blows my mind sometimes. So like stuff you can add that like seems so innocuous, but maybe it's like breaks caching somewhere or whatever, and like all of a sudden everything takes twice as long to check. And I think that's the biggest thing. It's just that like every change we made was knowing the exact impact. And for most libraries, it was the opposite. And like, that's not to say that any of it was like obviously bad or anything. It's just that without knowing, like you're just bound to hit cases sometimes where like something that seems really innocuous just is like really, again, it might be that like it broke some caching scenario where TypeScript in the past was able to like reuse, most of when you'd like repeat some type to like infer it a second time, it was able to reuse that. And now it doesn't for whatever reason, like some extra, context leaked in or something like that. And yeah, now it takes like 3 times longer to like check your repo or whatever it is because of that. So that's probably the biggest thing in terms of type performance, is just having the insight there. And then obviously like building those intuitions as well. Like of course, that makes it a lot easier to get to a point where things are working well in the first place. Since I built the like naive version that didn't work at all in terms of type performance and just kept iterating until it got better, build much better intuitions about like, okay, I should start with like an approach that looks a little bit more like this, and then hopefully I won't have as far to iterate. In terms of like runtime error messages being helpful and descriptive, that was definitely something that from the beginning, I guess, just felt super important. And I wanted to like come up with a sort of unique strategy for dealing with that. And I think like classically the error messages that are the worst are unions, because they're actually very hard to give good error messages for because like how do you say like in a succinct way, like, okay, it could have been any of these 10 things and it was none of them. Like, how do you describe why it was none of them? So I did a fair amount of work specifically around that case and around customizing error messages in a way that like they could automatically be composed into a union. So like if you like most errors, you can kind of customize as if you were completing the phrase like must be blank, and you can customize actual as like was blank. So that's kind of the like default error message format in ArkType. You can change that, but one of the really big advantages of like using a format like that is that we can take the like blanks that you filled in and put them into like compose them into a union error message that is really easy to read and understand. Whereas if you kind of just like arbitrarily wrote whatever format you want in some complete sentence, like we wouldn't actually be able to reuse that in a way that made it easy to parse. So like this way, when we create the union error message, we can actually go through and kind of like try to collapse as much stuff as we can. So for example, if there's like lots of errors on every branch at the same path, we can like kind of collapse those together and say like this path had to be like one of these 5 things or something like that, instead of saying like this object had to have a foo key that was this, or this object had to have a foo key that was that. So like there's one way that you can kind of pull things together. Another is like I guess, oh man, I lost my train of thought a little bit on this one. I'm gonna be honest with you guys. But I'll just say that like essentially there's several ways where we have like optimizations that will like iterate over union error messages and try to collapse them down to make them as readable as possible. And I think generally like it really helps a ton with just being able to like get a top level like human readable summary of what went wrong. And then you still get all the like introspectability. You can like iterate over the array and like check the individual errors and map them and do whatever stuff you need there. But yeah, I think like having that top level kind of like, okay, at a glance, like what went wrong here, and having that try very hard to just make the description of the errors as clear as possible, even when they start to get complex, definitely is like a really big selling point, I think, the library. That is really a lot better than like most of the other stuff that I've seen out there as a solution for those problems.
So that means you've implemented like logic within the type system to like compose those errors, right?
Yeah, so there's specifically like some logic within the like union node that's like, how do I create my error message? And it will kind of like iterate over its component errors and like, yeah, apply some of that kind of like merging logic that says like, okay, a bunch of them occurred at this one path, or like a bunch of them occurred like based on this one value. Or like I said before, maybe even one of the most impactful things would be like being able to automatically discriminate the union so that, we can just eliminate a huge number of cases that wouldn't be relevant based on like a property that you provided, and just give you the like, the information about why the one specific case that seemed to be the one you were actually trying to provide failed. So yeah, I feel like there's a huge amount of benefit there, and I'm excited for people to like delve more into some of those things, because I think it's like those are areas where people are just trying to like still build. It's a really new library, and people are still trying to like build analogies compared to like what they're used to from Zod. And I think a lot of people are still just like iterating over all the errors and like trying to figure this stuff out themselves. And it's good that they're introspectable and all that the same way. But I actually think there's even more that can be done to like, optimize those union error messages and like discriminate in a way that's really helpful. But then maybe we still need to provide like some additional context to say like, because sometimes it can be kind of surprising if we're like, why do you think that I'm trying to specify this branch? Like, oh, and it's because you said like kind was foo, but maybe 50 other properties matched on some other branch, right? I can't really figure that out in a performant way. So like there's lots of little nuances like that, and I'm excited to get more feedback from the community. But basically, I don't really think anyone else has even sort of like tried to like write really good union error messages. So like I think having something out there that tries to do some of that work for you is will be a big improvement. And yeah, it'll get even better as we get more feedback about what stuff is intuitive and what stuff isn't.
Yeah, I've done a bit of type gymnastics myself, and you get to the end, everything type checks, you check that error message, and you're like, how is any consumer going to know what that is supposed to mean? And then like being able to compose nice error messages in the type system, that's also like a large mental like learning hurdle as well. So like all of this being so easily accessible through like a nice API is a huge win.
Yeah, so I think that like what's one of the really cool things about ArkType's API is it's like an additional level of abstraction, obviously, compared to a standard API where, I mean, first of all, we can build whatever syntax we want into the language. So that's pretty cool. But second of all, like the primary mechanism for giving error messages isn't like the standard TypeScript, like sort of we return the type that you should have passed in. And then you get whatever TypeScript happens to generate for that error message. And that really wouldn't even work in like any kind of, it would not work. Well, first of all, you couldn't type like these kind of like these like validated strings. You can't write them like that. It has to be like as a function input that sort of thing is validated. But second of all, like even if you could for certain things, it would be really, really hard to read, like you're describing. Like how would we ever expect an external consumer to be able to understand any of this? And so basically, like if you haven't seen what an ArkType error message looks like, if you for example, like miss a parenthesis in like one of the types you're typing, or like reference like string, and leave out the N or whatever it is, you'll get like something like strig isn't assignable to, and then in quotes, it'll say something like, strig is unresolvable, or it'll say like, missing right parenthesis before like array or something like that. You'll get this kind of like, it seems like the kind of error you'd get in your editor, but you're getting it like in a string as the reason why your type isn't valid. And with the extension, it just kind of like actually will inline that part of it for you and just extract it out. And so when you type something wrong, you'll just see something like string is unresolvable, or you'll just see the part that says like, missing right parenthesis before array. But basically, like because of this kind of approach we're using to validate your definition input, we can give whatever type, we can give whatever custom error message we want at a type level, right? So like we're not relying on TypeScript to say, okay, like here was the structure we wanted, and here was the structure you gave us, and so like whatever arbitrary issue there happened to be, like TypeScript will generate some potentially complex message for that, if it's including unions and including like deeply nested arrays or tuples or whatever it is. But for us, we're always kind of in control of what what feedback we're giving you at a type level anyway. So we kind of bypass like having to rely on TypeScript to give a good error message for those cases, and instead can just tell you like, and a lot of time it'll literally tell you like what to do, like try this instead, or just like change your string to be this. And it's like all just happening in TypeScript's type system. But it kind of like makes it does create that extra layer of abstraction where like you are not actually thinking about TypeScript giving you like inscrutable error messages anymore when you're defining an ArkType definition, because you're dealing with like our error message feedback that is like just a very like, yes, obviously we have to use TypeScript's type system at some point, but like the only interface to it is just that like you get a message back that says like your input was not assignable to, here's your custom string error message. So like we get to kind of bypass a lot of that. And I think it leads to way better experiences in many cases, because like you said, it's just way too easy as types get more complex to just like get things. You need some kind of like parser or whatever. Maybe you like, copy paste it into an LLM or something. I don't know. But like, it's such a mess. I remember like when I was first getting started, I saw an error message and it was like ... and I forget how many like billions of characters it was that it like omitted. But I like remember doing some math and it was like 7 times longer than like all the Harry Potter books combined or something. And I was like, like you generated that? Like, what? I mean, it's crazy. Of course, like no one would ever be able to parse that. But like there's a lot of scenarios that aren't quite like that extreme, but are still like, there's no way that like a human could understand this. So yeah, that's one of the big improvements I think that ArkType makes by having a little bit more control over like what feedback we give there.